Well, hello everyone, and thank you for joining us today on our webinar about clipping. Clip, clip, hooray. This webinar is going to show you how you can get just the data you need by employing the technique known as clipping. My name is Dale Lutz. I'm one of the co-founders of Safe Software, been doing this for nearly 28 years, and I'm joined today by Olivia.
Hi, my name is Olivia. I'm a senior software developer. I work on the geometry team. And next up is Kaylin.
Hey, my name is Kaylin, and I'm a technical support specialist on the desktop side.
Thanks, Olivia and Kaylin. I think with that, we'll figure out how to shut off our webcams and we'll carry on. I know Olivia and Kaylin have a lot of really good demos lined up to show us. We're going to learn a lot today, so let's see what they have in store. So yes, we're going to do a little overview about what clipping is, and then we'll get right into a demo so you can see how it actually works. Then we'll look at how you can begin to use the clipper, and then Olivia is going to take us on kind of a deeper tour of all the ins and outs of clipping that's available to you with our products. And lastly, we'll finish up with a bunch of other resources, and of course we'll be hanging around to do some questions and answers with you at the end, as well as throughout. You can ask questions, and one of us, whoever isn't presenting, will be pleased to get back. We've also might be joined by some other help as well. But yes, today we're going to be using FME as our platform for all of our demonstrations, and it really is an overall enterprise integration platform. It's evolved into that, but it has a strong background in spatial data, and particularly today we're going to be focusing on a very important spatial data manipulation known as clipping. FME manifests in about 4 different ways. On the desktop, you build and run data workflows. You draw a graph from what the data is that you have. The blue things are the operations you want to perform. One of those is clipping. And then you can put some writers down to output that data to really any format we support. And so that's where we're going to be spending most of our time today, is inside of FME Desktop, looking at the nuances of clipping workflows. Once you have that workflow working really well, you can take it across to FME Server, which can be run on premises, on your servers, or out in the cloud. And then you can have those workspaces fire up and run in response to stimulus while you're sleeping. So if an email arrives, they can wake up and do some work preparing data. If there's a webhook that fires, if something arrives in a queue, if there's a real-time event of some kind, FME Server is all about taking these workflows we drew and authored on the desktop and running them hands-free up on the server. FME Cloud is really just a different business model for FME Server, where you pay by the hour, and we give you a machine that has FME Server on it, and you don't have to worry about dealing with any of the maintenance and admin of that machine. You just pay for the time that you use. And lastly, we do have a couple of mobile clients. You can use FME AR to see your data in augmented reality superimposed upon the geospatial location that it belongs, or you can use it in model mode to kind of get a sense of what something looks like as a different kind of visualizer. And lastly, we have Fme Data Express, which is a way of executing these workflows from mobile that you authored back on desktop and are sitting up on server. In terms of data support, there's around 500 different formats that FME works with today from all kinds of data. And you can see the history of our expansion through different types of data. Of course, today we're really looking at spatial stuff, so we're going to be concentrating primarily in the GIS and CAD space, but Olivia will show you how some of these other data types end up playing into clipping workflows as well. So the whole point of our talk today is so that you'll leave this familiar with how you can use clipping so you can get at the data that you need just for the problem that your organization needs to solve. And there's a variety of times this is useful, and we'll walk through a number of these today. And so I think with that, I'm going to hand it off to my friend Kaylin. Are you ready for your flash demo?
Hey Dale, thanks. Yeah, I am. So we're just going to give a quick flash demo to give you a sense of what can be accomplished with FME's Clipper Transformer. I'm going to read out a scenario and then we'll hop into the FME workbench itself. So a common task is to calculate the area of parks to assess what ground maintenance needs to be carried out over the year. Of course, this should not include area occupied by buildings. So we're going to use FME Desktop to build a workspace that subtracts building footprints from parks before measuring the area of those parks. And so I'm going to hop into Workbench quickly. Everyone should see FME Desktop and then some data here. So I'm going to get started with this parks map info tab file, and I'm just going to drag and drop it right on the splash screen, and you can see that a reader dialog box came up. And so here I could set some parameters or assign a coordinate system, but I'm going to go ahead and just add it right to the canvas. So I can click this little down arrow on the reader, and I can get a quick preview of all the attributes that are associated with this feature type. Now, before running, I'm going to make sure I'm in feature caching mode, and I'm going to do a partial run, and we can take a look at the parks data. So you'll see that also kicks off the log file down here. And this is a really good place for troubleshooting, but we're not going to spend too much time there right now. So let's take a look at the parks data. And so we can zoom in. You see that FME nicely overlaid it on a background map for us. Okay, so now it's time to get the buildings in here. So we can just do the same process to get our building data. And we'll hit OK. And before running that, I'm actually going to build the rest of my workspace. So I'm going to type on the canvas and use the quick add function to add a transformer. So this area calculator is going to calculate the area of these parks and store it in a new attribute called total park area. From here, we can drop down a clipper. And in this case, the buildings is going to be the clipper, and the candidate is going to be the park layer. And just to make this nicer, I'm going to right click and move up. And then we're going to add one more area calculator to the outside port so that we're just getting the total park land area without buildings. And we'll add an inspector, even though I have feature caching on, and we can go ahead and run this. And so after taking a look, now we have two new attributes. And if we inspect, we can see that the appropriate buildings have been clipped out of our park features. And this concludes the first demo. So I'm going to hop back into the slides. So the Clipper transformer overview, we like to use the analogy, the cookie cutter analogy, where the data is the dough and the Clipper is the cookie cutter itself. So in case you're new to the FME Clipper transformer, we're going to start off by defining some terms. So the Clipper input port. So this can be areas or solids which are overlaid on candidate features to identify which of those features fall inside or outside of the Clipper. Those features are then split where they cross boundaries with the Clipper, and the geometry of the Clipper features are unchanged and they're discarded after use, so they will not come out of the Clipper transformer. Moving on to the candidate input port, this is the first change from 2021 to 2022 that you'll see. It used to be called the Clippy input port, but we've renamed it as candidate. So what are candidate features? This can be features of any geometry which are compared to the clippers and then split into multiple sections along the clipper boundaries if necessary. Each section is output as either falling inside or outside of the clipper, and they can also receive attributes from the clipper through a spatial join process. So there's a section in the clipper for attribute accumulation. Candidate geometry is only altered if it intersects with the clipper. So if it falls wholly inside or wholly outside the clipper, the geometry will remain untouched. So just a few more terms. When we're talking about boundary, we can think of this like the outline of our geometry. And inside meaning geometries that fall within the clipper feature, and outside meaning geometries that fall outside of the clipper feature. So in this screenshot, if the fire response boundary layer was our clipper feature, this small sliver of the neighborhood boundary would come out of the inside port and the rest would come out the outside port. So common use cases for clipping. So spatial analysis can be pretty processing intensive, especially if you're working with a large number of features, and clipping is kind of one way around this. So whether you're clipping to an area of interest, or maybe you got all your data from different sources and you want to align them to one extent, you can clip to reduce data volumes, or maybe you want to work with a subset of your data while you're still designing your workflow, and then you can apply it to a larger data set when you're happy with the output. So related transformers. So many transformers can assess spatial relationships and perform spatial joins, so analyzing topology or merging attributes and sometimes modifying geometry. And the Clipper is considered a modifying transformer because it changes the input dataset's geometry, whereas the spatial filter and spatial relator will compute relationships between points, curves, and area geometries, but will not change the geometry. You'll notice I also have some overlaying transformers on the slide. That's not an exhaustive list. I think there might be one or two missing, line on area and point on area. Technically, overlaying transformers are also considered modifying transformers, but it's more commonly used to combine or superimpose geometries in order to identify spatial relationships, opposed to clipping them or like breaking them up. So the first demonstration is going to be clipping map layers to an area of interest. And I think this is how I learned about clipping when I went to school for GIS, so I thought it would be a good place to start. I'll just read off this scenario and then we'll switch back into FME Workbench. So a GIS analyst is investigating how accessible Toronto schools are for students that bike or use bike paths to get to school. They would like to begin looking for new areas in each neighborhood to create more bike paths in the coming years. But they would firstly like to know where existing bike paths are as well as school locations. And so we've kind of made an example that will mimic this scenario. Okay, so I already have my readers in here all set up, and I did make use of a user parameter, which I will briefly explain. So first things first, let's just run our data and take a look at what's being brought into FME. So we'll use our visual preview window. Wow, that might be a lot of data to look at, and it's kind of hard to digest like this. So I think we should build something that makes this a little bit easier for the analyst looking. So instead of looking at every single neighborhood, we're going to just look at neighborhoods on a per neighborhood basis. So first, I'm just going to come to my neighborhood layer and figure out what attribute is storing the neighborhood name. So I see area and description and area name. I'm pretty sure I used area description. So we're going to continue on with this. So where area description is like, and then I'll show you how I set up the user parameter. So we're going to test for neighborhood, and then we're going to clip that these two layers per the neighborhood boundary. So I've just used an attribute keeper to isolate the attribute I want, duplicated it so I can set it up with the import dataset user parameter function, just to show you. Here we go. So we can see now we have all of the neighborhood names and it's in a choice selection. So let's just go and make that no default value. And now we can add our clipper. So in this case, the neighborhood is going to be the clipper and our other two layers are going to be the candidate features. Now let's just right click and move up. Before running, I'm just going to quickly take a look at the clipper parameters, but I think all I'm going to do is have some clipper parameters be transferred over. So if I write this out to another application, I'll still know what bike paths are a part of what neighborhood. So you'll see now we can run the workspace. I'll be prompted for the neighborhood I would like to look at. And so I'm going to come back down and find Casa Loma, and we can go ahead and run this. So the user parameter just makes it a little bit easier to digest the data, and then the clipper transformer is getting us just the data we need. And we should have, yep, there's our attributes from the neighborhood layer. So just going to continue on. The second demo we have, I have set up for you is to reduce data volumes with clipping. So maybe you were working on a parks project and you had a big file of satellite imagery, but you really didn't need it all. You just needed the imagery that was contained in the parks themselves. So the goal here is to use FME's new Clipper transformer to clip ECW satellite imagery file with a park polygon shapefile. And the result should be manageably sized files that will render quickly in the visual preview window and can be worked with in a much faster manner. And so I already have this one set up, but we can see the satellite imagery and we have our park polygon reader and the Clipper transformer. Now, There is a option to use to set raster parameters, but honestly, in this case, the defaults were okay with me. So I'm just going to go ahead and run the data, and then we'll be able to see quickly how FME will. So now we can just see we can work with these 4 parks really easily, and maybe we could import them into ArcGIS Online and then digitize the pathways, for example, or just work with them in a different way. And I think this is where I hand it off to Olivia, if I'm not mistaken.
Thanks, Kaylin. And now we're going to take a deeper dive into the Clipper transformer. So the Clipper transformer supports a number of fundamental geometry clipping operations. Clipper geometries can be areas, rasters, or solids, and candidate geometries can be anything in our geometry model. And of these fundamental operations, 6 of which are new for FME 2022, curve solid, area solid, surface area, surface solid, solid area, and raster solid clipping are all new. We can also clip text candidates. So for text geometries, the locations are clipped, but the text strings are not. So for this example, if I have an orange candidate or an orange clipper polygon and a text geometry, the text geometry would come out the inside port because the point location is inside the polygon. If clipping the text string is required, consider using a text stroker first. The Clipper also supports geometry collections, so aggregate and multi-geometries. For Clipper features, each area and solid in the Clipper feature are treated as independent Clipper geometries, and each part in a candidate feature is clipped independently, but hierarchy is preserved on output. So in this case, I have an orange multi-area with 2 parts, and that is being clipped with the blue polygon, and the result of the inside port would be a multi-area with 2 parts. So this is what the Clipper transformer looks like in Workbench. On the left, you can see what it looks like on the canvas, and we've already seen the Clipper and candidate input ports in action, as well as the inside and outside output ports, but we will also talk about the remnant output port and the rejected output port a bit later. And on the right, you see the Clipper parameter dialog box, as is when you dropped on a Clipper in FME 2022. And there are a lot of parameters here. There is a lot of control you can take when defining your clipping operation, but you don't need to know what all the parameters do all the time. In fact, you don't need to know what most of the parameters do most of the time to use the Clipper effectively. But I am going to talk about all of them here so that if you ever do need to change one of these parameters from their default values, you can remember and you can use this webinar as a resource. So with that, we're going to take a tour through the various pieces of functionality in the Clipper using the parameter dialog as our map. So the first stop on our journey are these 2 parameters, multiple clippers and clippers arrive first. Both of these parameters let you optimize your workspaces based on additional information you can tell the Clipper. So multiple clippers no says, I guarantee that there will only be 1 Clipper feature coming to the Clipper transformer. And clippers arrive first says, I guarantee that all of the Clipper features will arrive before all the candidate features in the workspace. You can make either of these guarantees. The Clipper can leverage that information to run faster, especially for larger data sets. If either of these parameters are used and the assumption is not true, Clipper features will be rejected with the rejection code extra Clipper feature. So when a feature is rejected, it will come out the rejected port, and there are workbench level options to choose what to do in case of those types of errors. So I'm going to dive into a demo for this case, and it's a game I like to play called FME Racing. So I'm going to set everything up first, and then I'll set the scene. All right, and they're off. And so I'll talk a little bit about what this workspace is doing. So this workspace is reading world polygons, and then it is reading point locations in the world, and it is clipping the point candidates with the world clippers. And these are running the same version of FME. Both of the left and the right are running FME 2022.0. They are both working with the same data sets. They are both using the same version of the Clipper, and they are both reading the world polygons first. And I know this because the world reader, it comes before the points reader in the navigator. The only difference between these 2 workspaces is that on the left, Clippers arrive first is left at the default value of no. I'm making no assumptions about the order of features in my workspace. And on the right, Clipper's arrive first is set to yes, which says I am making assumption about the order of features in my workspace. And as you can see, these workspaces behave very differently when run. On the left, we actually haven't even started clipping the points yet. We are still reading all of the points and waiting till we are done reading all of the points. Where on the right, we are reading the points from the reader and we are clipping them with polygons concurrently. So I'm actually not going to let this finish because it takes a little while to run, but the version on the left will run in 13 minutes and the version on the right will run in 3 minutes, 20 seconds, which means for this data flow, it's about 4 times faster. All right, next up on our driving tour, we have a parameter called overlapping clippers. And this parameter lets you control the behavior when a candidate is inside more than one overlapping clipper at once. So the top left picture is our input data. We have a green triangle, which is our candidate geometry. And we have 2 polygons, clipper 1 and clipper 2, that are our clipper geometries. The first option, clip original candidates, compares the original green triangle to each of the clipper geometries independently. So in this case, we would get 2 features out the inside port. The first would be the part of the green triangle that is inside clipper 1, and the second would be the part of the original green triangle that is inside clipper 2. And one interesting thing to note is that the 2 inside features that would come out the inside port would overlap in the same location that the original clipper geometries overlapped. The second parameter is clipped interim results. And in this parameter, there's actually 3 features coming out the inside port. There is one that's the part of the green triangle that was only inside clipper 1. The second is the part of the green triangle that is only inside clipper 2. And the third is the part of the green triangle that is inside both clipper 1 and clipper 2. And the third and default option is called clip only outside remainders. And the way this works is the green triangle is compared to each clipper in order. So first, the green triangle is compared to clipper 1. Everything that's in the green triangle that's inside clipper 1 is output the inside port, and the part of the green triangle that was outside clipper 1 is compared to clipper 2. And there will be a demo about this case a little bit later. Next parameter on our driving tour is called the candidate's Unclipper boundary parameter. And so in this case, I have a point candidate and an orange area clipper, and the point happens to lie on the boundary of the area. And so if the parameter is set to output is inside, the point candidate will come out the inside port. If it's set to output is outside, it'll come out the outside port. And if the parameter is set to output is inside and outside, 2 point features will leave the Clipper transformer, one out the inside port and one out the outside port. The next parameter on our driving tour is called invalid parts handling. And this lets you control the behavior of rejected features with aggregate and multi-geometries. So there are some geometries that are invalid for clipping. For example, null geometries don't have a spatial location, so they can't be classified as either inside or outside a clipper geometry. So this parameter lets you control what happens if you have an aggregate or multi-geometry where some of the parts are valid and can be clipped, and some of the parts are invalid for clipping and cannot be clipped. So the default value, reject whole feature, will reject an entire geometry collection if any part is invalid. And the other option, reject parts only, will only reject the invalid parts of a geometry collection and will continue processing the valid parts. So I have a demo case ready about where you might want to use the reject parts only mode. So let me set the scene. So in this scenario, I have polygons that represent the neighborhoods in Vancouver, and I have aggregates with points, and the points represent the locations of street trees in the city of Vancouver. And I have one aggregate per type of street tree, so they're all different species. And I've actually already created my workflow and run it, and I didn't get the output I expected. And the reason I didn't get the output I expected is because my translation failed, and it failed because a feature came out the rejected port. So let's take a look at that feature now. So it came out the rejected port, and it had the rejection code invalid geometry null. And if I look at my geometry, I do see that there are some null parts. So it looks like there were some street trees in my data set that lost their appearances along the way. Well, I've thought about this, and for my particular case, I've decided that's okay. So what I'm going to do is I'm going to add a writer. I'm going to hook it up to the rejected port. I'm going to go into the Clipper, and I'm going to change invalid parts handling from reject whole feature to reject parts only. And I'm going to run it again. And this time I did get the results I expected, and I'm able to continue with my analysis. All right, next up on our driving tour is a group of parameters called the area on area Z values. And these parameters let you control which elevations are used when clipping areas with areas. So the first parameter, preserve Z from, controls whether the elevations in the output areas will come from the candidate area, the clipper area, or both. The second parameter, missing Z values, controls how elevations are interpreted for new vertices that may be introduced during clipping. And the third parameter, connect Z mode, controls how curves should be joined when they have different elevations at the place that they join. And so I actually have two demo cases here to show how these three parameters work together to solve elevation needs. In the first one, I have this scenario. I have some roof polygons, and someone has reported a possible roof leak as well as an approximate location. And I'd like to clip my roof polygons with the location of the possible leak. The roof polygons have elevations and are planar, and the possible leak location is a 2D feature, so I can't compare the elevations between these two data sets. So here I've already added readers, and I'm going to drop down the Clipper transformer. I'm going to use the area of interest as my clipper, my roof polygons as my candidate. I'm going to hook up a couple of inspectors, and I'm going to run it. I get this. So you can see that the clipped results follow the slope of the original data. And these are the default parameters for the Clipper in FME 2022. So this was the default setting, and I didn't have to make any changes. But this is not the only interpretation for Z values on areas, which is why we offer so much control. All right, I also have another scenario about the area on area Z value parameters, and I'm going to set the scene. So in this case, I have two polygons. I have the dog off-leash area in Haddon Park, that's the orange polygon, and I have the boundary of the city park, which is a teal polygon. And I am looking to find the portion of the dog off-leash area that is not within the boundary of the city park, so I'm looking at the outside port. I also know a couple of things about this data set. I know that the X and Y units are in lat long, and I know that the Z values along the polygon boundaries represent the elevation along the boundary in meters. So I've already set up a workspace for this, and I'm going to hit run. And if I take a look at my data set, I see something I don't quite expect. I see that it starts off where I expect, but as I walk along the outside of this region, I see that the values become negative. So it looks like we are actually descending below seawater here. And that's because I was using the default parameters here for the area and area Z values, and they're not applicable in this case. So in this case, because I want the elevation data from both the city boundary and the dog off-leash boundary, I'm going to change this to candidate and clipper. And because my units of X and Y and Z are different, I'm actually going to change this from planar interpolation to linear interpolation. And I'm going to change the connect Z mode parameter from snap to single vertex to ignore, because I'm looking to make a path if they are different so that I can see what the differences are. And if I run this again and look at the elevation data, I can see that the elevation data is now what I expect. And I also see that there is a difference between the elevation data here along the city boundary, which is 1.88 meters, and the elevation data here along the dog off-leash area boundary, which is 1.89 meters. And so now I can take this information and use it in the rest of my analysis. All right, returning to the Clipper parameter dialog for a driving tour. The next is a section of parameters called measures. Measures are additional pieces of information that can be associated per vertex in a geometry. So the first parameter, preserve measures from, controls whether the measures in the output areas will come from the candidate area, the clipper area, or both. And this only applies for area clipping. And the second parameter, missing measure values, controls how to interpolate measures for new vertices that are introduced during clipping. And this applies anytime candidates with measures are clipped, not just for area clipping. So I have a demo case for this as well, and I can set the scene. In this demo, I have 3 data sets. I have polygons that represent the neighborhoods in Vancouver. I have points that represent the stations for a rapid transit line. We call it the SkyTrain. And I have lines that represent the path this rapid transit line takes through the city of Vancouver. And I would like to clip the lines with the neighborhoods of the city of Vancouver. But there is an additional thing to keep in mind here, which is that my lines have measures. And at each point along the path the train takes through Vancouver, I have a measure value that is the ID of the closest station to each vertex along the track. So I've already set up my demo, so I'm just going to hit run. If I look at the very first feature in my clipped inside results, I see something kind of surprising. I see that my first vertex, I have a closest station ID of 15.26 and on and on and on. And that's because when we were inserting new vertices along the line, we were interpolating linearly, but that is not what I want for this data set. So what I'm going to do is I'm going to open the Clipper parameter dialog. I'm going to look at the measures group. I'm going to change missing measure values from linear interpolation to nearest vertex. I'm going to hit OK. I'm going to run it again. And now I look, my first point is closest to station 15, and then the next point is closest to station 16, which is what I expected. All right, returning to the Clipper parameter dialog along our driving tour. The next is the parameter section called vector candidates with a parameter called a tolerance. And the tolerance is the minimum distance between the two geometries in 2D before they are considered equal in ground units. This is used in curve area and area clipping, and it is designed for microscopic tolerances. For macroscopic data completion, I would recommend the segment snapping algorithm in the snapper and anchored snapper transformers. So in this case, I'm going to talk a little bit more about the tolerance parameter and also the remnants output port, which is the last output port that we haven't seen yet. So I have a demo case here, and I'm going to run it first. So in this case, this orange polygon is my clipper, and this pink polygon is my candidate. And you can see that pink polygon has a 0 width spike. And when I clip this pink polygon, I get this is the clipped inside result. This is the outside result. And then I get the spike of the remnants port. So because the spike did not have an area inside, it does not come out either the inside or outside port, but you will still get your data outside the remnants port. And the remnants don't only happen with 0 width or degenerate parts of polygons. It can also happen with nearly degenerate or nearly 0 width parts of polygons. So I'm going to run the second case. And you can see in this case, my spike is not a 0 width, but is nearly 0 width. If our units in this case were meters, and this is smaller than the distance of one atom. And I'll get the same results I got with the 0 width spike. I get clipped inside results, clipped outside results, and I get the spike of the remnants port. All right, next up, returning to our driving tour, is the group called raster candidates. And there are 2 parameters in this group. The first parameter, preserve raster extents, controls whether the extents on the output features should be the original raster extents or the clipped extents, whether the extents should shrink when being clipped. And the second parameter, determine cell location by, controls whether a cell is clipped by the center of the cell or by the bounding box of the cell. Next up on our driving tour is a parameter group called attribute accumulation. And you've seen this before. The attribute accumulation parameters control whether and how attributes from Clipper features are transferred to candidate features. You can also generate a list from overlapping clippers, which is most useful in overlapping clippers clip interim results mode, which is new for FME 2022. And I have a demo case for this, and I'm going to set the scene. So I have here addresses for previous customers to Captain Oven's Pizza, and we have decided to execute different marketing strategies based on the driving distance to each address. So I also have here 3 service area polygons. The smallest one is all of the addresses that are within a 3-minute drive to Captain Oven's Pizza. The middle one is all the addresses that are within a 6-minute drive of Captain's Pizza, and the largest one are all the addresses within a 9 minutes drive. So what we've decided to do is that for everyone within a 9-minute drive, we're going to send them a promotional email. Everyone that's also within a 6-minute drive is also going to get a mailed flyer. And everyone within a 3-minute drive is also going to get a mailed coupon along with their mailed flyer and promotional email. So the way I'm going to set this up is I'm going to drop down a Clipper transformer. I'm going to use the Clipper service areas as my Clipper features, the street addresses as my candidate features. Because I know that my Clipper areas overlap, I'm going to change this to clip interim results. And I'm going to generate a list from overlapping Clippers. I'm going to give it a list name. And I'm going to say marketing strategy. I'll connect an inspector and I'll run it. And so of the 5,000 previous customers, we've decided we're going to have a marketing campaign for the closest 1,700. And if we look at the points, we see that at this point, we're only going to have one marketing strategy, the promotional email. And a point over here, we're going to have two marketing strategies, the mailed flyer and the promotional email. And if we go in all the way to the center, we're going to have a mailed coupon, a mailed flyer, and a promotional email. And the very last parameter on a driving tour is the clipped indicator. The clipped indicator parameter controls the attribute name that will be used to signify whether the candidate feature was split into multiple output features. In other words, whether the feature was clipped or the geometry was modified. The value will be yes. The value of the attribute will be yes if the geometry has been modified, or no if the geometry has not been modified. And that is the end of our driving tour of the Clipper parameters, but there are a couple more things I want to talk about. The first of which is upgrading the Clipper transformer from previous versions of FME. So this is a Clipper I dropped down to a workspace in FME 2021. And if I would like to upgrade it to version 14 in FME 2022, I right-click, I click Upgrade Transformer, yes, and there's a couple of things I want to draw your attention to. The first is that the parameters have been reordered and moved into new groups, so they may not line up one-to-one from where they were before. The second thing is that the tolerance value of none has been upgraded to a tolerance value of automatic. That is because for Clipper version 14 in FME 2022, automatic tolerance is the smallest supported tolerance. There was also a parameter called preserved lines as path segments that no longer exists. We have a new default behavior that we think will work for everybody. All right, so I look happy with all of this. I'm going to hit OK. And that's it. That's my upgraded Clipper transformer. I do have one more demo case about upgrading Clippers, so I'm going to bring that over now. And here I am clipping a box with some solids that represent buildings in New York City. So I'm actually going to run this, and I made this workspace in FME 2021. So my Clipper features are 5 solids, and they look like this, and they are right next to each other. My candidate geometry is a box that looks like this, and when I ran the Clipper, I had one output feature. And the reason for this is that previous versions of the Clipper would perform a pre-processing step on solid Clipper geometries where they would be dissolved together. So when I upgrade this Clipper in FME 2022, and I run it again, you can see that I actually get a different number of output features. I get 5, and that's because this pre-processing step was removed. And now I get one clipped inside result per Clipper solid. If this is not the behavior you're looking for, then I would recommend dropping down a solid dissolver transformer to explicitly dissolve your Clipper solids before sending them to the Clipper. And if I run this again, you can see I get one clipped inside feature now, which is the same behavior that I had before. But I actually, if I was upgrading this workspace, I'd take a look at it. It looks like the original intention of the workspace was to dissolve the Clipper solids together instead of performing a clipping operation. So I would probably upgrade the workspace like this and leave it like that. All right, and now I have a couple of performance tips and tricks I'd like to share. The first would be to upgrade clippers in existing workspaces to Clipper version 14. This may not have a performance improvement, but I've also seen cases between 8 and 40 times faster with the transformer upgrade. I would consider keeping only the attributes you need with the attribute keeper. I'd also consider using the multiple clippers no or clippers arrive first yes options to optimize based on feature order. There's also something else I can do when doing area clipping, so I'm going to set the scene. My goal was to calculate the total swamp area per state in Australia, and I've actually already run my analysis. So the way I set up my analysis is that I use the swamp polygons as my clipper geometries, and I use the state polygons as my candidate geometries. So I would clip the states with the swamps, and then I had an aggregator grouped by state name, so I'd have one aggregate geometry per state, then I would calculate the area, and then I'd write out the area to a CSV file. And this took 35.1 seconds to run for me. But I actually know a couple of things about this data set. I know that my swamp polygons don't overlap with each other. I know my Australian states don't overlap with each other. And I know I'm only looking at the results on the inside port. So what I can actually do instead is I can swap my clipper and candidate geometries. And I'm going to go in here and turn on attribute merging. I'm going to run it again. So this time, instead of running in 35 seconds, it took 12.5 seconds, which is more than 2 times as fast. I also have one more performance tip I can share, which is to consider pre-sorting your Clipper features to take advantage of ordering guarantees. So especially in clip outside remainders mode, we always compare candidate features to Clipper features in order, and there is a potential for performance improvement by pre-sorting your Clipper geometries to an optimal order. Unfortunately, there's no easy heuristic I can give. This optimal order needs to be determined through experimentation, and I would really only recommend this approach if you're using the same data set over and over and it is a bottleneck in your workflow. So in that case, don't waste time sorting through the data you don't need. Use clipping to get what you are looking for when you need it. And with that, I think it's back to Dale.
Thanks very much, Olivia and Kaylin. Well, I hope you've enjoyed this drive through all of the different aspects of clipping, starting with kind of the most basic use scenarios and advancing through some of the most advanced options we've baked in. I think that the Clipper that's in FME 2022 is well suited to solve pretty much any data subsetting problem you're ever going to want to have when it comes to spatial data. So I hope all of you will be able to take advantage of the FME Clipper so that you can work with only the geometric data that's valuable to your scenarios. So what's next? Well, right now you can catch us in Q&A, so be ready to, or already writing in your questions and we'll be answering. But if you want to talk to us after when we're off the air, always help yourself to info@safe.com. And of course, we have a free trial there, and as well, you can upgrade from older FMEs too. And most importantly, apply the workspaces to your own data challenges. We're going to have all of these that we've shown today available for you to download as part of the follow-up email. In terms of actually licensing FME for your own use, we have subscriptions that are a great way for organizations that don't know exactly their seat count or want to just be able to use as much or as little of FME as they want. And there's a variety of options there. You can buy licenses off of us that let you get going right away, and then you can pay us each year to get updates, which are helpful when there's smaller numbers of users, or you can go for a cloud deployment, and there's a variety of things there that are available too. A bunch of resources that we've got. You'll get these slides afterwards with all the links, and we may chat some of these out right now, but I know that our Knowledge Center has been updated over on the FME community with some of the latest things you saw today, so you can read more about these scenarios there as well. If you are part of our FME community, and we really do welcome people to that. Last time I heard, I think there's around 20,000 members in that community, so don't miss out, be part of that. There is a webinar badge that you can claim, and that'll be added to your profile. So there it is. As well, we are part of the Gartner research groups in order to improve our product and be on top of latest industry directions and trends. And so we value your feedback. And so you can contribute a review. We can also give you that link as well. If you're looking for a really great conference to attend, you can come and meet Kaylin and Olivia there and talk clipping all you want face to face, along with all the rest of the SAFE staff. We'll be having that 24th, 26th, called the Peak of Data Integration, and it looks to be a wonderful conference. I've had a chance to review the user talks that are going to be there, and they are really, really amazing. So you won't want to miss out. Do register now. And you can take a look at all the rest of the webinars we've got coming, as well as our archive of old ones at safe.com/webinars. And so with that, we'll head on over to some Q&A and see what kind of questions you've stumped us with.
Hey.
Hi. I think Olivia is having some connection issue. Yeah, but do you have any question that you may want to like address or like talk in details?
Yeah, there's two here I can quickly go over. Is the Clipper capable of doing 3D clipping, not just 2.5D? Yeah, so the FME 2022 Clipper can clip points, curves, areas, rasters with solids. We should be able to do it. And the other one that stood out was if I'm using the Clipper and nothing is being clipped, something to check would be your coordinate system. Make sure that your layers exist in the same geographic space. I think that's about it though, unless there's any more live.
Yeah, if you haven't had a chance to like drop in your question during the webinar, you can do it now. Hi, Olivia.
Hi.
Oh. I just went over a couple questions from the QA report. I don't know if you had anything else that was standing out to you.
Yeah, so the one I remember going over last time the most was how the Clipper handled coordinate systems. And the answer is that it doesn't. It's coordinate system agnostic, and it assumes everything is in ground units. So if you're having clipping issues, try checking whether your data sets are in the same coordinate system.
And there was one last time too about clipping text. So in order to clip text, you have to text stroke first and then clip. I think we can pass along the recording now. And I think the workspaces can be found on that link too.
Yeah, I didn't realize that I mute myself, but yeah, the recording will be available. We will send out the follow-up email later today, and also it will be available on our website. Yeah, also the workspace. I think that we don't have any question to chat about. So I think I can wrap us up. Anything from you, Kaylin or Olivia?
No.
Okay. So if you do think of a question afterward, please feel free to reach out to us via live chat or info@safe.com. And thank you to everyone who joined our webinar today and also to our presenters. I will leave the webinar open for a few minutes longer just in case you have any question or you want to save any links from the chat. Also, we always love to hear your feedback and how we can improve our webinars. So please let us know what you thought of our webinar today through our surveys. I have chat out the link, and I think I will drop the link again here. Yeah, and hope you all have a great rest of your day, and thank you for attending our webinar today. Bye.
Thank you so much.